All right, good morning. Today we are starting into 3.3.1. So the 3.3 is what we're starting in. And this is with multiplication of decimals. I'm just gonna check and make sure we're good. Yes, on audio. Hopefully it's sharing the screen properly. And we've got chat open if anyone comes in and has questions. All right, so multiplying decimals, what you can do is you can just do the multiplication. I know that sounds crazy, but the way I like to remember it is if we have here 3.15 times 6.4. The way I like to think of it is I just multiply 315 times 64. I don't pay attention to those decimal points initially because they're not causing me any grief. They're not doing anything. And so on that, we take and we say, okay, 4 times 5 is 20. 4 times 1 is 4 plus 2 is 6. 4 times 3 is 12. I'm going to put a 0 here to be a placeholder because I'm doing tens. 6 times 5 is 30. So that becomes a 3. 6 times 1 is 6, plus 3 is 9. And 6 times 3 is 18. Now I do the plus. Now I'm going to have 0, 6, 1 here, 1 here, 0, 1 here. So 20160. Now's when I pay attention to the decimals. Now that I'm all done with the math, I'm going to look how many places are behind a decimal. 1, 2, 3. So I'm going to start with the decimal here. And I'm going to move it forward 1, 2, 3. And from that, I'm going to get the answer 20.160. And if I look at that, I'm good to go. I don't necessarily need this 0 on the end, but some people like to see it. Because I'm adding 0 in the thousands, yeah, that's fine. When I'm multiplying decimals, I'm just going to treat it the same as I would any other number. Then I'm just going to take and say, okay, there we go. How many decimals are there here? 1, 2, 3, 4. 4 places. So I'm just going to do the multiplication. 3 times 5, that's going to give me 15. 5 plus a 1. 3 times 2 is 6. 6 plus 1 is 7. 3 times 1 is going to give me 3. And then I'm going to say, okay, next, 1 times 5. I'm going to add 0 for this spot to keep track. That'll give me 5. 1 times 2 and 1 times 1. And then we're going to add those together and move over 4 decimal places. Or 3, excuse me. So on this, I have 1, 2, 3, 4. Yeah, because there's 3 and 1, 4. My brain itched for a minute for no reason. All right, now multiplying powers of 10. This is where we can get used to the idea of scientific notation. Every power of 10 moves the decimal to the right by 1. So if we're multiplying by 1,000, we just take that dot, 1, 2, 3. So if I have 5.9134, right? And I'm multiplying this by 1,000. I just take that dot 1, 2, 3 places over, I get 5913.4. That's a nice little shortcut you can use. Only with powers of 10 can you do that, because that's the base 10 number system that we're using. All right. Now let's talk about the area and perimeter of a circle. So the area can be found with the formula area is equal to pi r squared. Now the difference between a radius and a diameter. Diameter is from one side to the other. Radius is from the very center to the edge of the circle. So I like to think of it as a sprinkler on the lawn, those kind that pop up and spray out a round area, or even the gear-driven ones. They reach a circular pattern when they go around. Well, that's the radius. How far it is from the center to the edge is the radius. Diameter is just 2 times the radius. If we cut it in half, we'd have the same distance here as the same distance here. Whatever distance that is r. So now they're going to be using pi as 3.14 for this exercise. So here we have, find the area of a circle with radius 4 feet. So we say the area will be equal to pi 4 squared. When we do that, we'll get 16 times pi. Now, if I do large numbers, I'm going to use the pi key on my calculator. But for 16, it's a small enough number. 3.14 will give me an approximation. So I can say 3.14 times 16. And when I do, 6 times 4 is 24. 6 times 1 is 6, plus 2 is 8. 6 times 3 is 18. Put a 0 there to hold that place. 1 times 4 is going to be 4. 1 times 1 is 1. And 1 times 3 is 3. We'll add those together. Got 4. 8 plus 4 is 12. 0 and a 1. And that gives us 5024. How many things are behind a decimal? Well, let's have a look here. There's 1, 2. So that decimal is going to come over 1, 2. And from that, we get 50.24 feet squared. And the reason I know this is in square feet is it asks for the area. And to find the area, I'm multiplying 2 dimensions. So when I'm talking about area, I'm saying, hey, if I want to put grass in this space, how much would it take to fit the grass in this space? And grass, it's going to come in 2 dimensions, this way and this way. That's how I know its area. Why is it in squares? Because squares are easy to calculate. We just cut them on the edges to fit what we need. All right, so let's do some of the homework. Remember, when we have parentheses bump up against each other, it's like bunnies, they multiply. So here we have 3.04 times 0.02. 2 times 4 gives me 8. 2 times 0 gives me 0. 2 times 3 gives me 6. And now I'm going to say, okay, how many places are behind a decimal? Well, there's 1, 2, 3, 4. So we're going to start here and go 1, 2, 3, 4. So my answer is 0.0608. Now, for some people, that might cause some confusion. Matt, how come if I'm multiplying, I'm getting a smaller number out than I start with? Because I mean, 3.04 is a larger number. And here I'm times a really small number, I would think. How come I'm getting a smaller number? Well, I'd like to point out what our definitions are of division. Division is the same thing as repeated subtraction, or multiplication by the reciprocal. And when we do that with the multiplication by the reciprocal, we introduce fractions to it. So let's look at this as 3 and 1, or excuse me, 4 over 100 times 2 over 100. Well, let's use our previous skills and we'll say, okay, times and plus. 3 times 100 is 300 plus 4. We'll have 304 over 100 times 2 over 100. Now, when I do that work, I'm going to end up with 304 times 2. So 608 over, and there's 1, 2, 3, 4. So it'll be a 1 with 1, 2, 3, 4 zeros. So I'm ending up with 608 ten thousandths. Well, let's have a look here. We have the tenths, hundredths, thousandths, 10 thousandths. 608 ten thousandths. That's where those smaller numbers are coming from. Because I'm multiplying by a large number here, it's cutting down on how much is up here. Isn't that crazy? Multiplication is division. Makes my head hurt sometimes thinking about it. So that's how we end up with, like, this is 3 over 100. This is 14 over 100. We're going to get a smaller answer. And that's why we're moving these decimals, is to keep track of their place in the number system, because what we're playing with is fractions, because a decimal is a fraction. So do keep that in mind. Now, one thing we did not cover was the circumference of a circle. So I want to talk about that. If a circle is drawn, the circumference is if I want to put a fence around it. It's like the fence around it. So I like to think of it as the circumference. I know it's the circumference, but when I look at that, I think fence. Because that's what I'm talking about. I'm talking about if I were to take and cut the circle and put it into a string, how far would this be? Relationship, and that is the pi times the diameter. And for anyone who was in this morning's GED class, we were doing ratios. This is a ratio. It's just a super powerful one used all the time. Now, if I were to cut the diameter in half, is equal to my R. So if I multiply both sides by 2, I get D is equal to 2R. So I could also call that pi times 2R. Now, in math, we like to move the 2 to the front there because it's a constant. So is pi, but it's one of those things where we always feel better about ourselves putting the most recognizable things forward in math. So we'll call that 2 pi R. So we are told here, find the area and circumference of a circle with radius 6 centimeters. So the first thing I'm going to do is I'm going to draw my circle. Don't worry, it doesn't have to be a perfect circle. Then I'm going to take and mark my radius. My radius will be 6 centimeters. Now I'm going to find the area and circumference, and I'm going to start with the circumference. If I'm putting up a fence, how long is this line? If I were to cut it right here, unwind it, how far would that be? Notice it's only in one direction. It's like putting up a fence. So is it going to come out in centimeters cubed? No. Centimeters squared? No, it's going to be in centimeters. Why? Because it says centimeters right here. Why won't it be squared or cubed? Because it's only going to be in this one direction right here. So with that, I'm going to say, okay, the formula is equal to 2 pi r. For this, we're using, you can use the 3.14. That helps us with the GD. So we'll say 2 times 3.14 times 6. And that's going to be our circumference. Now, being me, I'm going to use that commutative property of multiplication and associative property, and I'm just going to move their order around. So C is equal to 2 times 6 times 3.14. And then I'm going to associate these two. And that last one didn't turn out well. By grouping them. So I get 12 times 3.14. And now that's math I can do. So I say 3.14 times 12. 2 times 4 is 8. 2 times 1 is 2. 2 times 3 is 6. All right. Put a 0 here so I don't lose track of it because I'm starting off here in the tens column. That's why we put that 0 there, so we don't forget, hey, that's where I'm starting off. All right, so 1 times 4 is 4. 1 times 1 is 1, and 1 times 3 is 3. Add those together, and I get 8. 2 plus 4 is 6. 6 plus 1 is 7, and 3. Now I have 2 places behind a decimal. So now I'm going to take this to 2 places. And so my circumference is equal to 37.68 centimeters. That tells me if I had to cut a piece of string to fit around this, that's how big it would need to be. All right, now the area. The area is found by the formula pi r squared. And so now I'm going to get instead, r is 6, so I'm going to say the area is equal to pi times 6 squared. Now I'm going to think back to my Aunt Sally or my sister or my adult supervisor, however I want to remember it. And I'm going to say, okay, parentheses come first. There's nothing to do inside. Okay, exponents. So 6 squared gives me 36 times pi. Now I'm going to look at that and say, okay, we have 3.14 times 36. Okay, Matt, why are you putting the longer number on the top? That was a habit that was developed in me when I was younger. You can do it the other way, it just gets harder to keep track of it. So think of it like this. You want your longest winded person, you keep the most track of them. You all know the type I'm talking about. You know, the one who you go to talk to him for 2 seconds. Hey, about my lawnmower. And next thing you know, an hour later, it's like the SpongeBob, 1 hour later, and you're like, seriously. You keep track of them when you're in a group. The longest winded one's the one that'll take the most energy to deal with. And so the one with the most decimal, one with the most places to keep track of, so that includes after the decimal, that's the one that goes on top. It makes our lives immensely easier because the way we use our column system. If you do it the other way, you can. It just gets hairy and it makes my hair stand up, even though I don't have very much left. All right, so now we go 6 times 4 gives me 24. 6 times 1 is 6, plus 2 is 8. 6 times 3 gives me 18. Now I'm going to put that 0 because I can't forget it's in a 10 spot. So I'm really multiplying by 30. 3 times 4 is going to be 12. So put a 2 and a 1. 3 times 1 is 3 plus 1 is 4. And 3 times 3 is 9. Going to add those together and I'm going to have 4, 0, put the 1 here, 3, put the 1 here, and 11 in front. So we have 11304, and we have 2 decimal places. So boom, boom. We get 113.04 centimeters squared. Because in this one, we're playing with the 2 directions. So it's going to be in square. That's if I put square tiles in there, how many of them would fit in there? All right, now let's get to something a little bit crazier, just in case our brains don't hurt enough. And I'm going to show you guys something a little bit crazy. So I'm going to show you the traditional algorithm as it was taught to me. And so we're going to say, okay, let's say that we have 7.12 divided by 4. This one's okay. 4 will go into 7 one time. 1 times 4 is 4. Draw that line, change the sign. See this decimal? I'm just going to make sure it goes up right where it's at. That's all I have to do on that. So now I've got a 3, bring down my 1. 4 will go into 31 7 times. 7 times 4 is 28. Draw that line, change that sign. 31 minus 28 gives me 3. Bring down that 2. Then I'm going to say, okay, 4 will go into 32 8 times. 8 times 4 is 32. Draw that line, change the sign, remainder 0. I'm done. Now, at that point, if it didn't have a remainder, where after the decimal, I can just start adding zeros once I'm beyond a decimal until I get to the last number. If I find it has a pattern, then it's going to have what we call a repetend, or it'll terminate. Either it'll stop or it'll go on forever with a pattern that I can say, okay, this is, what we can expect, put a bar above it. If it's a weird number, yeah, I've managed to stumble into something fun that's called irrationals. Don't worry, you won't run into those through division. And now that I said that, someone in the comments will be like, Matt, you're an idiot. Because when you look at e to the pi I squared, who am I kidding? E to the pi I is something else that's fun. But we get the general gist, I hope. Okay, so here we have 5 divided by 8. Oh, that looks like one of my scores. 5 out of 8. All right. So here, I know that it won't go in, right? So I can put a 0 here. I don't need to. I remember when we discovered we didn't have to put the 0 in front of the decimal. I was so excited. And then they're like, you put the 0 in front. You don't have to. It just looks prettier. Unless you write like I do. Okay. So now we're going to say, okay, by putting that decimal, now I can break it into smaller pieces because this is wholes and these are tenths. And so now I can go, well, 6 times 8 is 48. So 6 times 8 gives me 48. Oh my. Hey, there we go. Draw the line, change the sign. 50 minus 48, 5 goes to a 40, that goes to a 10. 10 minus 8 gives me 2. Bring down that 0. 8 will go into 20 twice. 2 times 8 gives me 16. Draw the line, change the sign, got a 4. Bring down that 0. 8 will go into 45 times. 5 times 8 gives me 40. Draw the line, change the sign. We're done. So this one shows the going on forever. What we can do is we can just write this as 4.73 with a bar above it. Because we're saying, look, you can go on as long as you want. This is what we call a repetend. That comes up in some of our mathematical definitions. A repetend just means, hey, I can tell you what's after that. Let me put a bar above it. Yeah, that's cool. The one thing we didn't show you in this how to do is this kind of problem, and this is where I get excited. So we're going to do that real quick together. It'll be fun. For anyone at home, I'm looking at everyone all excited and I'm getting looks back like, is this guy okay? I'm not sure I'm okay with this. You know, it's normal. Welcome to my class. All right, so here we have 26.08. So we have 26.08. And we're going to divide that by 3.2. And so we're going to say, okay, what do I do? Well, it's not fun keeping track of decimals on this side of things. We're like, oh no, we don't want to keep track of you. You're not helping us. So yeah, we're going to move it, but why can I move it? Why is that allowed? Well, yeah, if it's a whole number, it's a lot easier. But why can I do that? And I'm going to show you guys something real quick. This is something that I get super happy about. I think you're on the right track. I'm going to remind everyone that this is a fraction bar. So look, we have 3.2 over 26.08. Now, what is 5 divided by 5 equal to? We have that rule. Any number divided by itself is equal to 1 as long as that number does not equal 0. Only crazy people try to divide by 0. It never works. If somebody tells you, yes, it does, they did not understand the math class they were taking. Does not equal infinity because it's not defined. Now, if I were to multiply this by 10 over 10, here, we'll clean that up. What is 10 divided by 10? 1. Any number times 1 is itself. Well, look what would happen to this decimal. So I'm actually using the power of 1 when I move that decimal. If I could just randomly move decimals, I'd do that all day on my bank account. Be like, oh yeah, you think I got 10 cents in there? Bam, it's 100 million now. What for? Let me move that decimal. Watch what happens. The reason I can do this is it has that relationship of that division, which means it's also a fraction. And I can multiply it by 1 or 10 divided by 10. So when I'm moving that decimal, all I'm doing is multiplying it by powers of 10, the same way we do when we clear fractions as we're solving equations. I know I get a little too happy about math, but when I was a kid, I never understood, why can I move a decimal here and I can't move it there? Like, trust me. It's one of those things like one time my doctor told me, you need to lose some weight. I looked at her, oh, that'll be easy. And she's like, what? How do you figure? I said, well, we'll just change my specific gravity. Maybe put me on the moon. She's like, you need to lose mass. Nice try. Oh, well, that's different. That's a lot more difficult. A little bit of knowledge is dangerous and all that. So the reason we're moving this is we're multiplying both by 10. So it's 10 divided by 10, or multiplying by 1. That's where we get the 32. And now we're at 260.8. If I move it 2 places, that's by 100. If I move it 3, it's 1,000. However many places I'm moving that decimal, put a 1 in front of it and zeros behind it, that'll tell you how many zeros are on it. And for anyone who struggles with scientific notation, that might help you. Because suddenly you'll see, oh, they're not magically moving decimals like a bank account. There's a reason behind it. So, I know I get a little too excited by math. I'm sorry. All right, so when I do this kind of math, I'm going to look at this and say, okay, 32 will go into 26 0 times. Fine. 36 will go into 260. Not sure. So I'm going to say to myself, hey, brain, look at this. That's a 32, so it's closer to 30. How many times will 30 go into 26? Or 3 go into 26? Because I'm ignoring this 0. I'm just looking at this 3. 3 would go into 26. Well, 7 times would be 21. 8 times would be 24. 9 times would be 9 times 3 is 27, too much. So I don't need 9, I'm gonna try 8. And this is where I fish. So I'm gonna say, okay, 32 times 8, and what do I get out of that? 8 times 2 gives me 16. 8 times 3 gives me 24 plus 1, 256. Oh, that's such a beautiful number. I should have seen it coming. All right, so now we say, well, that'll go in about 8 times. 8 times 32 gives me 256. I'm going to draw the line, change a sign, and now I've got 6 to a 5, 10. 10 minus 6 is 4. 5 minus 5 is 0. 2 minus 2 is 0. And now I'm going to bring down my 8. And I'm not going to miss this important step. Here's my decimal here. So here's my decimal here. Because now I'm having to cut it into even smaller pieces to try to figure it out. 32 will go into 48. Well, once, because twice would be 64, right? 1 times 32 is 32. Draw that line, change the sign. And now we've got, 8 minus 2 is 6. 4 minus 3 is 1. And we're going to bring a 0. We can always bring down zeros after that decimal. We can always cut it into smaller pieces. So now 32 will go into 160. Well, 3 will go into 15 5 times. So what's 32 times 5? Well, 5 times 2 is 10. 5 times 3 is 15 plus 1. Oh, look how cute that is. So 5 times 32 is 160. Draw the line, change the sign, and I am done.